Hi, everyone, and welcome to Let's Talk Risk with Dr. Naveen Agarwal, where each week we talk about a topic related to risk management of medical devices. I'm your host, Naveen Agarwal, principal and founder at Achieve, where my personal mission is to help you achieve success in risk management. In this episode, I'm joined by Andy David, who is an expert in embedded software development, currently working in the automotive industry on a hydrogen-powered car. He also has prior experience in heavy equipment and aerospace industry. This conversation is an example of how we can learn from experts in different industries and share knowledge that we can bring back into our medical device industry. We talked about many topics related to risk management and safety, as well as standards that should be used appropriately in front of a live audience as part of a LinkedIn live audio event. You're about to hear a recording of our conversation. So sit back, relax, and enjoy the show. Let's get going with that. So thanks again for coming on today.
Brilliant. It's an absolute pleasure to be here. It's, as I said earlier, it's the highlight of the end of my week. It's an absolute highlight at the end of my week. I'm based in UK, so it's a little after 4 o'clock in the afternoon here. So it's a lovely way to round off the working week. I saw myself and Naveen met when one of my old colleagues, John Ward, was a guest speaker, and I saw John was participating. So I thought, I've got to get involved with that. John's a brilliant, fabulous guy to work with. And it was great to reconnect with John. As for me, my background, I'm an embedded software engineer. I work at the moment in automotive systems. I'm involved in a fantastic project developing a hydrogen-powered vehicle with a very different business model to do with sale of service rather than sale of product. And it really, as we might talk about later, it really changes how we approach the design of the car. But I started with embedded systems back in 1991 when I did an internship at IBM at Hursley Park, just outside of Winchester. I think it's where they invented the Winchester disc back when everything was in black and white. And it was brilliant, and it really changed my life in terms of what my own perception of software was. So I was doing a bachelor's degree in computer science. I got a brilliant internship at IBM, and it was absolutely brilliant. And I was involved in, first of all, writing an audio layer for a very early desktop conferencing system. I don't think there were any desktop conferencing systems in the world at the time. And this did video and audio over ISDN and token ring Ethernet and things like that. I was involved in the audio processing of that. And then later on, I was writing diagnostics for a portable terminal. It was a very low-powered, ruggedized PC, and I thought, this is fun. It's technical, it's challenging, it's interesting. I get to work with electronics, and it was more of a systems feeling, and it turned my life around. Later on, I did a master's degree in VLSI design, and again, it was like in terms of my professional life, it was a life-changing experience, and I thought it's low-level software is the place for me. In the mid-90s, I started working in hydraulics, and I was part of a team developing a very novel hydraulic management system, a flow control valve, and it was huge fun. And they had a small team we were all quite young engineers, and they didn't tell us how hard it was going to be. And they shut us in this room and said, right, come back when it's working. And we managed to pull it off. And then it was absolutely brilliant. I was there for over a decade. But then I moved from industrial systems into aerospace. I worked on a couple of aircraft. I worked on the 777, the Boeing 777 nose wheel steering system, and the Airbus A400M military transport plane. And from then, I sort of worked my way into automotive systems because as a boy, I loved cars. I guess we call them petrol heads here. I think in the States you call them gear heads. And I tell you, I had these things memorized. I'd get the motor show guides, and I'd memorize every single statistic and characteristic. And one of my friends would say to me things like, "And man, what's the trunk capacity of a Mark III Ford Capri in cubic feet?" And I'd know it. And after a while, I thought I spent too much time with it. But yes, it's that's my journey. I'm a software engineer. I work on embedded systems for safety critical systems, and my current interests are automotive systems and particularly things that are sustainable and deal with renewable energy.
Oh, that's really cool, and such a fascinating experience and background, Andy. It's amazing to hear. And
I've been very lucky.
Yeah, so now you're so much into cars. This must be like a kind of dream job or dream project for you to work on hydrogen powered car. Tell us a little bit about that.
Well, the car is the company's called River Simple. It's the car we're building is a small, I suppose we'd call it a local car. It's not a city car. It's not intended for long journeys in a straight line. When you look at the statistics about the kind of journeys people take, there's a huge proportion. It's something like 85% or something journeys are within a 10-mile radius of where you live. And so we thought, okay, let's crack that problem first. Let's see what we can do. How clean, how efficient can we make a car that does that job? And the car itself is called the Rasa, R-A-S-A, and it comes from the Latin phrase tabula rasa, which means clean slate. And the founder of the company, Hugo Spowers, he's a genius. He's a complete genius. This is the most well thought through, most watertight set of ideas I've ever come across in my life. The idea is that the car is, we started. Well, Hugo's background was that he was a classic car restorer, and he has a background in automotive sport, in motor racing. So he was a driver, then he was a team manager, and then he had a successful business restoring classic cars. And he got out of motor racing for environmental reasons, which is odd enough because he got into it for environmental reasons, thinking if he could demonstrate environmental improvements in successful racing vehicles, it would be a very quick and effective way of getting those changes into production vehicles. But he said, the argument is true, it still takes too long. So he got out of motorsport and he got out of cars altogether until he met a guy who said, have you seen these things called hydrogen fuel cells? They take hydrogen and oxygen from the atmosphere, and they produce electricity and water, and they're quite lightweight. And Hugo thought, oh, that's quite interesting, and he took a piece of paper and he drew in the middle of the paper a hydrogen fuel cell, and had a think and thought, well, what does the rest of the car look like? And that was a completely novel approach. There are hydrogen cars available that you can go and get right now. There's the Toyota Mirai, which is brilliant. There's the Honda Clarity, I think it's called, which will be brilliant because everything that comes out of Honda is brilliant. There's the Hyundai Nexo, and these are all great cars, but they're from companies with a colossal legacy in making what I would call a traditional car with a petrol or a diesel engine, or latterly, of course, battery electric. So that's probably where they started. They probably took a chassis, perfectly good chassis if you've got a big, heavy power plant, and thought, how do we make this work with hydrogen? So they started from a different stake in the ground. And that's the reason I think that one of the reasons why the River Simple car is so different, because we started with a fuel cell, drew the rest of the car. We didn't start with the car and then try and replace an engine with a fuel cell. So the noticeable difference is that I think the Hyundai and they're all, and the Toyota, they're all around 120, 140 kilowatts fuel cell, but the River Simple car is 10 kilowatts. It's ultra lightweight, it's 4-wheel drive, and And if I do say so, it's got some pretty smart software in it to deal with energy management, because 10 horsepower will pull the skin off a rice pudding, but only quite slowly. It's not a great deal. I mean, to put it into context, I've got a motorbike with 75 horsepower that weighs 200 kilos, and the River Simple car is 650 kilos. Typical car, I think the average car weight for production cars at the moment is 1,350 kilos, maybe 1,400. So it's very lightweight.
Wow.
And but I can talk. I could take up the whole rest of the day just with the car.
But what I'm hearing you say is that certain design choices are being made deliberately because of the how the original vision evolved, right?
Yes,
you
absolutely.
are making design choices.
Yeah.
So in this context, Andy, first I want to kind of talk to you about just your perspective. We talk about risk and safety in these conversations, so let's get back to that theme. From your view and in the context of what you are doing, how do you just think about the term risk to begin with? What does it mean to you?
Well, risk for me is the potential for something to happen which could lead to injury, death, or damage.
Okay.
And with something like a hydrogen car, the obvious risks are, people worry about hydrogen. It's a fuel, it's a chemical fuel, so it likes to liberate its energy very, very easily. In truth, it's fundamentally safer than a petrol car, but it's the perception is hydrogen is very dangerous. Well, of course it is. It's a fuel. Petrol is very dangerous, under conditions. Diesel is very dangerous, and even batteries themselves are very, very dangerous. But that's the first obvious danger. The second is that you're moving people around in a box, and sometimes you can move at speed, and all it takes is for you to not look where you're going or lose control. But of course, there's also things that you can hit with your vehicle. If you have something like an uncommanded torque. So imagine you're sitting in a car park, the car's on, and suddenly it rolls forward without you asking it to. And there have been, in the automotive history, examples of cars doing this in the past, and it's, of course, a terrible thing. As a driver, there are things you can do to stop that. And of course, as engineers, there are things we can do just to make the system not do that in the first place. The risk is it's the combination of where the car is, how it's being used. I'm sort of blurring myself into hazard here a bit, but risk is really the possibility of something going wrong with the car or how you're operating it that can lead to damage or injury or death or some loss of money, something like that.
So in this context, this concept is very similar to how we view risk in the medical device business. At the end of the day, we are talking about sort of a safety impact in terms of the harm to the patient or the user. And you're kind of thinking in a similar way, right?
Yeah, it seems that way, yes. It seems sensible.
Now, another term that gets brought up is safety. So is there a difference between risk and safety? I'm sure they are related, but how do you view the two?
Well, safety is what we do. It's the activities that we perform so that the risk is mitigated, so that the probability goes away. So if we've defined a hazard, and a hazard is a set of conditions by which a risk can lead to injury or damage or death, then the safety is what we do in response to that, is how do we respond to that hazard so that there's no risk, or that we reduce the risk as much as practically possible.
Got it. So you are viewing safety more as something that we aim to achieve through our understanding of risk and how we manage those risks. Is that right?
Yes, I think that's, in a minute I'm going to think of why that doesn't hold water. But for now, I think, yes, safety is my response to risks that we've identified. And of course, an inherent approach. I mean, it's It exists in our activities and in our thoughts, but it's my safety concept is a direct response to the hazards which I have, which we have identified.
Oh, interesting. So, I mean, we talk about risk management in our business quite a lot with the intention of delivering safe products. And what I'm hearing you say is that safety is something you think about as doing, is as a response to what your understanding of the risks are. Is that correct?
Yes, I would say so. I mean, we with the RASA, we did a HARA, a hazard analysis and risk assessment, and we looked at ways in which the functions that the car performs. That was where we started. What does the car do? It produces acceleration, it steers, it contains hydrogen, it converts energy, it carries a payload, things like that. A list that was actually surprisingly hard to define. We took operational states of the car, what it's being subject to. Are you driving it? Are you parking? Are you parking inside or outside? Are you driving on a country road or a fast road? Driving at night? Is it raining? Things like that. And then we looked at status of the vehicle. Is it stationary? Is it switched on? Is it maneuvering? Is it driving forward? Things like that. And we had these three axes, and we looked at every combination of these three things, and we thought, in what way could the car malfunction and produce an unsafe or produce a hazard? In what way could a malfunction in any combination of those three things produce a hazard which could hurt someone?
Got it.
And we came up with a substantial number. And then, of course, the functional safety standard that we use, ISO 26262, gave us guidance on how we could grade those in terms of severity, exposure, and controllability. And from then, that would define the automotive safety integrity level, which guides us with what activities we perform on certain functions, on certain requirements, design, implementation, verification, specific techniques to help us make sure, A, we understand what we're doing, B, we understand how we're going about doing it and implementing it, and how we then demonstrate that we've achieved these objectives. So that was the collection of that is our safety concept.
Oh, that's really awesome. So, guys, we're at a point where I think I'm going to now invite you guys to participate. So please don't be shy. And that's the whole point of this conversation, is to have more discussion with you. So let me know. Now, when we were talking a little bit, Andy, before we went live, you mentioned that ISO 26262, it was kind of not a straightforward decision in your business, in your current project, to follow that standard. Can you say a little bit more about that?
Yes, that's right. Well, ISO 26262, I'll call it ISO 26.
Okay.
Just for short. It's the International Automotive Functional Safety Standard for systems, electrical and electronic engineering, and software engineering. In the past, I've done projects using RTCA D0178B for aerospace systems, and IEC 61508 for defense systems. So it would seem, why wouldn't you use 26262 as your functional safety standard? Well, the reason for us was we weren't building a normal car, and we were building it. It will be for the next several years. We're not going to hit anything like major production. We're planning factories building 5,000 a year, which is it's absolutely small fry in the automotive world. So these domain-specific functional safety standards they're very specific to things like your production volumes, I suppose your procurement, and how large they are, how many people are in them. So, I mean, if we build 5,000 cars a year and they're two-seaters, that's potentially 10,000 people in the cars every year. You could think of it something like that. Whereas for something like DR178C, if you're building, I don't know how many 747s Boeing make a year, but they seat, I don't know, maybe 400 people. But they fly at 30 odd thousand feet at 550 miles an hour, and so on. So the profiles are quite different. So they're tailored specifically to their domains. And it wasn't immediately obvious that we had the same criteria as someone like Ford or Toyota or Nissan. So we considered other functional safety standards. And we came to 2.6 at the end because it's a good standard. It is the automotive standard. And one of the things we'd be asked straight away would be, you're an automotive manufacturer. Why aren't you using the automotive standard for your systems, electrical, electronic, and software engineering? And we'd have to explain, and it's a long question. And unless there's significant benefits in using a different standard, then it was a question for us.
Interesting.
And it was an interesting study in itself.
Yeah. So what I'm hearing you say is that, you are in such a kind of field or space that it is so new. We had to think about it a little bit differently, but at the same time, you are still considered part of the automotive industry. So expectation would be to follow these standards. And one very quick point I want to make before I invite David, I know you're waiting, is you described that, hey, the ISO 2.6 may not be applicable at different scales in different situations, those criteria. And I think this is a challenge that we face in the medical device industry also, right? Because our products are so diverse, different risk profile, different scales, different ways. And I think the one way they have taken care of that is having a more general practice standard for risk management and leaving the specific acceptability criteria out of the 14971 and holding top management responsible for establishing those criteria appropriate to their stakeholders. So I think that's a very interesting way our industry has gone. And I think there's a balance there. So David, I want to invite you. Please unmute your mic and share what you have in mind.
Great. Can you hear me?
Yes, I can. Thank you.
Perfect. Thank you, Andy. Fascinating discussion. I'm kind of formulating my question as I'm listening to you talk. It's related to the mandatory nature of some of these standards. It sounded from the way you were talking that there was some choices to make as to which standards you were going to comply with. And maybe this is a question you can jump into as well, Naveen, but in the medical device industry, a lot of these standards are required. And I'm just wondering how that makes a difference.
Andy, you want to just go first, and then I'll share some thoughts on that.
Well, first of all, David, congratulations on a fabulous first name. It's one of my favorites.
It works both ways.
Yes, I've only got first names. As far as I understand, ISO 2.6 is not mandatory. But in my experience, often the questions about why you didn't do something are much harder than the doing of the thing. So, and it's, of course, we all know that in this industry, we need a functional safety standard. We could, if we wanted to, just engineer our way through it, and it would probably be okay. But for the times it's not, then it's a lot easier to figure out why and to get to the truth if you've followed a functional safety standard. So I don't think it's mandatory that we do it.
Yeah.
That said, I don't quite know, but it's. I think we'd be absolute fools if we didn't. There's a huge amount of expertise and experience, and it's all very well for me to be critical of certain parts of it, but I think to do something better would be enormously difficult.
Yep.
So my approach is, it's brilliant. I just want to use it and get what I can from it.
I would say the same thing, David, that I think people have same perception of ISO 14971 as well. That is mandatory. It's legally required. No, it is a state-of-the-art consensus standard. It's a good idea to do it, to use it, but no one will take you to court if you didn't do it. So I think the point here is that if you do risk management better than everybody else in the world, that you think your way is better than the standard, then maybe you should be part of the standard development too, right? Standard is the way to progress make our society go forward. So I hope that clarifies the discussion. And I say this to folks in my training courses that it's a good idea for you to do it, but if you have a better idea, nobody's stopping you from that as well. Christopher, welcome. Thanks for joining, and I want to invite you to share your thoughts. Please unmute your mic. Chris, can you hear me? Okay, we'll give him a moment there. So, David, does that make sense to you? I hope that sort of answered your questions or not.
Can you hear me?
Yeah.
Yeah.
And if I can summarize and maybe get your comments. So it seems to me that the reason for choosing to comply with these standards, at least part of the reason would be obvious, a business reason to lower your risk or to potentially improve your safety. That seems obvious.
Yeah, absolutely. Because it is considered to be state of the art. There's a reason why we practice state of the art, because it makes life easier. Everybody has done so much work and we advance the field together. Chris, go ahead. I think you are ready to share what you have in mind. Go ahead.
Can you hear me?
Yes, I can.
Okay. Well, it's interesting that I joined this particular Friday chat because I'm a veteran myself in the fuel cell industry. I spent the first 7 years of my career in systems engineering for fuel cell systems for automotive applications and stationary power. So
excellent.
I worked with a variety of large industry players in development of PEM fuel cell systems for automotive applications, starting in the actually in the late 90s, going way back. So this looks like a great car, and so I want to applaud you, Andy, and hope that it's a success. Well, one of the things that I wanted to just mention with respect to risk and with respect to functional safety is that 62304 is the medical device standard for software development life cycles, and it's actually based on 61508. So there is some connection there.
Yes,
and as we know, 62304 is also a risk standard, just like 14971 is. It addresses risk management. So there's some cross pollination there. But I would also say that 61508 is a good standard for medical device practitioners, medical device engineers, and quality practitioners to look at, because you can learn a lot from that standard with respect to functional safety and take those learnings over into your own space.
That's awesome, Chris.
I agree.
That's awesome that you shared that. And I think I want to highlight a point here is that when we have a compliance mind, when we have a compliance focus, we would say, let me just do that because that's what I think is required. And what you just mentioned, Chris, that many people will do 62304 for software, but you're mentioning, hey, there's something else that exists parallel to it. There's other standard that could be relevant. And when you have a safety mindset, I think you will probably go broader and do the right things, because these are all good standards. Ed, you are requesting to speak, so I'm gonna bring you on here. Fascinating discussion. I want to, just a spoiler alert. Chris, you're gonna be a guest very soon, so I'm looking forward to talking to you about these topics in detail. Congratulations on completing Boston again.
Thank you.
This is amazing. You did the Boston Marathon, and I'm really looking forward to our conversation. Yes, exactly.
Yes, thank you.
And by the way, Chris did it for a good cause. He's raising funds for a very good cause as well. So
for Mass Pioneer, check out my profile.
Yep.
And you'll see.
Yep. So we have a group of folks who are so interesting to talk to, and I appreciate you guys being a part of this conversation. I can't wait to talk to you, Chris, in a couple of weeks from now. So guys, keep an eye on that announcement coming up soon. Ed, welcome. Go ahead. Please share what you have in mind.
Oh, yes. This is a very interesting presentation, Naveen. I'm glad you put it together. One thing I heard in here was we've got all these other standards that do risk. Well, in medical devices, 14971 is designed as a catch-all, would be one way of saying it, where all of these risk analysis from 62304, 60601, 62366, all of the standards need to all be brought together into 14971, because 14971 is a device standard and it includes all of the aspects of the device. And so at the eighth clause in there, we do an overall residual risk evaluation. And that's where we gather the risk from all of the different aspects of the product, whether it be AI or biocompatibility or software or whatever. They all have to be analyzed at the overall stage. So we need to bring together the results of all the risk analyses from all of the various standards that are used in developing the product so that we have a true overall residual risk. In other words, what we have to remember is we're looking at, with 14971, what the patient and the user sees. Mm-hmm. And they're going to see the results of the system, mm-hmm. the entire product, not these individual aspects. So I think that's something that we sometimes overlook.
Yeah, that's a great point.
Groups, the different groups of people that are working on their part, they're focused on what they do. But at some point, we need to bring the whole device together, because that's what our patient, our user sees.
And then I think we would expect us internally to look at all applicable standards, right?
Yes,
correct.
And
then I think ISO 14971 is brilliant in that perspective. That's not that prescriptive that, hey, here's a list, do it and you are done. Unfortunately, many people look at 14971 that way, Ed. I know that's a practice.
Oh, yes.
But the intent is do risk management right, which means look at everything that is applicable. So I know we can talk about this a lot, and that's actually one of the things I'm trying to get across through our conversations is that, let's think about risk from this point of view, that we do things right. Let's do them right. So anything else, guys? I know we are hitting the 30-minute mark here, but anybody else from the audience who would like to participate? Okay, if not, just a couple of quick housekeeping announcements before I invite Andy to share his closing thoughts. Guys, if you miss these events, they are recorded, and you can find a recording with an article actually summarizing key points on my newsletter. And you can find the link to my newsletter in the event here. In every event announcement, I put a link. You can go check it out and, subscribe or not subscribe, but you can find these articles and recordings on my newsletter, because that's the way we can capture this knowledge that we are generating right now with some analysis. And the second thing is that you don't even have to wait for a formal announcement for these events. If you love them, block your calendar for 11 a.m. Eastern every Friday, because we are going to be talking every Friday, 11 a.m. Eastern. And that way you will know, hey, at this time, we can go have an interesting conversation. With that, I want to thank all of you for attending, guys. And David, Chris, and Ed sharing your thoughts. Andy, I want to invite you to just share your closing thoughts.
I think it was a really good comment you made earlier, Naveen, that the way we push society forward is by developing standards. And clearly, as Chris said, 61508 is the generic standard. My understanding is it's from that standard that the domain-specific standards were developed. So there's clearly, the aims are the same, and clearly there's huge overlap between them. So I think if we're able to meet like this and discuss improvements, discuss thoughts, then a little body of knowledge will build. And if that at some point can be used to make a development and improvement in any standard, I think the chances are that it will find a way of rippling through the other standards as well for the other domains. And it could be use of new techniques or a different paradigm, like, for example, using agile instead of waterfall, something like that. Or it could be just a completely new set of thinking that we're yet to appreciate. So I think let's let's carry on these conversations. It's like I said, it's the highlight of the end of my week.
Oh, I appreciate
So it's I mean, whether that means I should get out more and have more friends, I don't know.
Well, you have so many friends here in the audience, guys. Connect with each other, network. That's also another sort
Yes,
of
absolutely.
objective of these discussions. And finally, I want to say, anyone in the audience, like, David and Andy, you kind of, see, I said your last name as your first name. Andy, you were in the audience, and you accepted my invitation to come. So anybody in the audience who would love to come on as a guest speaker, no preparation needed, no work. All you need is some time and connect, and just
Yes.
be able to share your thoughts, because all of us have things that we can share. So please reach out to me if you're interested. Just send me a message through LinkedIn, and I'll be very happy to chat with you. Maybe arrange a time for you to come to these events. Guys, it has been fascinating. I love it. We can have more and more conversations like these in the future. Thank you, everybody, for joining today. And everybody have a good weekend. We will connect again next week. Bye-bye.
Brilliant. It's been a pleasure. Thanks all.
Thank you.